In lesson 4.5, we're going to be looking at inverse trigonometric functions. This whole chapter has been about inverses, so we're going to continue to look at that and look at inverse trig functions. So there's a first example here. It says find the inverse of y equals, or f of x equals, the sine of x. And so we're going to write it as y equals sine of x. And we remember to find the inverse. What we do is we switch x and y. So x equals sine of y, and then we solve for y. Well, how do we get y by itself? We have to take the inverse cosine of both, the inverse sine of both sides. And that leaves us with inverse sine of x is equal to y, or y equals the inverse sine of x. And so those are inverses, which we really already knew that from when we worked through solving triangles. So below, we have the inverse of sine of x, inverse of cosine of x, and inverse of tangent of x. That's the reflection over the y equals x line. And what we have now is this is our value of 1, and this is -1. And then since this is inverse sine, it starts at 0 and travels along here. So we remember that it's just a reflection over the y equals x line. And we see the inverse of cosine and the inverse of tangent. Notice they're all reflections of the original trig functions over the y equals x line. Also, we can think we switched all of the x values and y values. Now, these are not functions because trig functions are not one-to-one. So what we're going to do, we're going to highlight the portions of the graph that would make each inverse a function. Now, there's different parts or different ways we can do this because this is a periodic function, so it keeps repeating over and over again. But we're going to stay as close to 0 as possible. We need to make sure we get each x value and each y value. So that highlighted portion is that's a function. All right, so what we need to do is we need to limit our range. So we only want the range to be from -pi/2 to pi/2. And our domain ends up being from -1 to 1. Cosine is a little bit different. We can't go from -pi/2 to pi/2. We actually can start here at 0 in our range and go all the way up to pi, and then that's it, because if we continued along there, it wouldn't be a function anymore. It has to pass the vertical line test. So our range for this one is from 0 to pi. And then tangent's pretty nice because it's just this part of the graph right here. And our range for that one is similar to inverse sine, except we have to use parentheses because we have asymptotes there. So it's from -pi/2 to pi/2. Says, then write the domain in interval notation of the original functions that make them one-to-one. So we actually do this fairly often. So over here, for our original function, this was the domain and range of inverse sine. But what would the domain of sine of x be? What would we want to talk about if we wanted to limit the domain? Well, that would be So we'll write it as y equals sine of x, and we would just want to go from negative pi over 2 to pi over 2. And for cosine, we'll put a semicolon again. We would just want that from 0 to pi. And tangent, so these are the original functions, not the inverse. So we're restricting our domain, and we've done this before in previous lessons with restricting the domain. Forgot the semicolon, and actually it's not a bracket, it's a parenthesis. So actually what we do is we get to this note down here to indicate that we want these restricted domains on our original function. We actually use capital letters to indicate we want the restricted domain. So if you see a capital S, that means it's restricting it from negative pi over 2 to pi over 2, and we can write that in interval notation now. So normally sine, when we graph sine, we just go on and on. But we only want that restricted part. So we just go from negative pi over 2 to pi over 2. So that's the sine of x. Inverse sine of x, so this is y equals capital S sine of x. Now I'm going to do y equals capital S inverse sine. And so that still goes through 0, 0, but it actually looks like this, where this goes from negative 1 to 1 as the domain, and the range is negative pi over 2 to pi over 2. Inverse cosine. We remember that inverse cosine looks like this. And it keeps going, but again, if we want to do y equals capital cosine, I think I might have said that wrong earlier, so we just want cosine, we would restrict our domain to just 0 to pi over 2, and then the inverse of that, so y equals inverse cosine, would look like this. Oops, that's not a very good drawing of that. And then inverse tangent. So tangent usually has lots of branches and goes on forever and ever, but there is y equals capital T tangent of x. That's our restricted domain. And then y equals inverse tangent with a capital T. Just looks like this. And so those are the graphs of the inverse functions. So we can call them functions now since we're limiting them to be one-to-one. So there's a few examples here